Hello everyone, myself Tushar Kumar and I am currently pursuing BTech in Chemical Engineering from NIT Warangal. So today we will discuss about matrices. So what is matrices? It is a rectangular arrangement of number in row and column. So let us take one example. If I arrange the number in this way and I take a square bracket over there like this, so we call that it is a matrix. So the main thing comes in this chapter, that is row and column. So what is row? The horizontal arrangement of number, we call them a row, and the vertical arrangement of number, we call them column. So how many rows are there in the matrix? So row 1, row 2, row 3. And how many columns are there in the matrix? Column 1, column 2. So in matrix there can be any number of rows and any number of columns. So we call it a matrix because elements are arranged in a rectangular pattern. So now we will see the order of matrix. If in a matrix M denote the number of rows and N denotes the number of columns, so the order of the matrix will be M cross N. Here M represents the number of rows and N represents the number of columns. So what is the order of this matrix? So we simply count the number of rows. There are 3. And how many columns are there? 2. So 3 cross 2 is the order of this matrix. We can read it either 3 cross 2 or 3 by 2. It is not a multiplication sign, it is just a cross. And the first element always indicate the number of rows and the second element always indicate the number of columns. So if I ask you one question, what are the total number of elements present in the matrix? So how can you find? You simply multiply the order 3 into 2, that will come out to be 6. So there are 6 elements present in the matrix. You don't need to count individual element 1, 2, 3, 4, 5, 6. You just multiply the order, it will give the total number of elements. Now we will see the general notation of the matrix. So we generally represent the matrix with the capital alphabet. First element A11, A12, A13, A21, A22, A23, A31, A32, A33. So it is a general notation of the matrix. So how many rows are there? 3. And how many columns are there? They also 3. So what is the order of this matrix? 3 cross 3. In compact form, we represent this matrix as A equal to Aij M cross N. Here M represents the number of rows and N represents the number of columns. Here Aij is a general element where first subscript I always indicate row number and J represent column number. So if I take this element A11, why we call this A11? Because it is present in first row and first column. Why we call this A22? Because it is present in second row and second column. So Aij represent in which row and column the particular element is present. As I said earlier, A11 it is present in first row and first column. Now we will see one question. If a matrix has 8 elements, what are the possible order it can have? So we know that if we multiply order, it will give the total number of elements. So the total number of element solution. Total number of element we get by multiplying number of row and number of column. So we know we have 8 elements. So we represent this 8 in the form of number of row and column. And we comment what are the possible order it can have. So the first possibility is 1 row and 8 column. Second possibility 8 row, 1 column. Third possibility 2 row, 4 column. And fourth possibility 4 row, 2 column. So here 4 type of order are possible. Now we will see another question. Construct a 2 cross 3 matrix where Aij equal to I plus j. So we know first element always indicate number of rows and second element always indicate number of column. So we know the order. So matrix A, we already know the order. Here 2 rows are there. A11, A2, A12, A13, A21, A22, A23. So we know order 2 cross 3. So there are 2 rows and 3 column. So we how can we calculate A11? So we have given a relation Aij equal to I plus j. So we put I equal to 1 or j equal to 1. 1 plus 1 equal to 2. 8, 1, 2. 1 plus 2, 3. A13, 1 plus 3 equal to 4. A21, 2 plus 1 equal to 3. A22, 2 plus 2 equal to 4. A23, 2 plus 3 equal to 5. So we know all the elements. So our required matrix is 2, 3, 4, 3, 4, 5. It is our required matrix. So in this way we can construct a matrix. Now we will see the classification of matrix. There are different type of matrix: horizontal matrix, row matrix, diagonal matrix, square matrix. Now we will study the square matrix. So square matrix, it is a matrix in which the number of rows is equal to the number of column. Is called square matrix. So I will give you one example: E11, E12, E21, E22. It is a square matrix because the number of rows is equal to the number of column. R1, R2, column 1, column 2. So what is the order of this matrix? 2 cross 2. In compact form, we write this square matrix as A equal to Aij m cross n, where m equal to n, because number of rows is equal to number of column. Or we can write A equal to Aij n cross n, because row is equal to number of column, because number of row is equal to number of column. Now we take a 3 by 3 matrix. A21, A22, A23, A31, A32, A33. So this is also a square matrix of order 3 cross 3. We know square has two diagonal, but in this matrix we study only one diagonal. This diagonal we have to study. We call this diagonal as principal diagonal or leading diagonal. If we add the diagonal element, we will get trace. So what is trace? Sum of all diagonal element. We can write as trace A. We take trace A11, sum of all diagonal element A22 plus A33, sum of all diagonal element. We also write as trace A equal to summation Aij. Here I goes from 1 to n, or we can write it trace A equal to summation I equal to 1 to n I, because here row number equal to column number. In diagonal we see row number equal to diagonal number, row number equal to diagonal number. So we, instead of writing Aij, we write Aii. Now we will see a question. Let A equal to Aij is a square matrix of order n and Aij equal to 2i plus 3j square. Find trace A. So we have to find trace A if the general element we have given 2i plus 3j square. Solution. We already know trace A equal to summation I equal to 1 to n Aij. We can also write it as summation I equal to 1 to n Aii, because in diagonal element it has row number equal to column number. So we take summation 1 to I, and Aii we have 2i plus 3j square. We put j equal to I, because row number equal to column number in diagonal element. So we take summation inside the bracket and the constant term, 2 is constant and 3 is constant, we take constant out of the summation. Summation I square 1 to n equal to 2, and we already know the sum of first natural number, because here summation I goes to 1 to n I, it is the sum of first n natural number. So we already know n plus 1 by 2 plus 3, and we also know the sum of square of first n natural number. So it is n plus 1 into 2n plus 1 by 6. So 2 cancel out, 3 to the 6. So we get n plus 1 plus n plus 1 2n plus 1 by 2. So this is our answer. Now we will see the addition of matrices. We can only add two matrices only when they have same order. I will give one example. If we have two matrices A11, A12, A21, A22. First matrix, second matrix B11, B12, B21, B22. So, what is the order of this matrix? 2 cross 2. And what is the order of this matrix? Also 2 cross 2. So, when we add two matrices, we add corresponding element. Means, first element will add up to first element and second element will add up to second element. So, we write A11 plus B11. Here A21 plus B21. Here A12 plus B12, A22 plus B22. This is our required matrix. In this way, we add two matrices. Let's take one example. 1, 2, 3, 4, 5, 0. We add these two matrices. What is the order of this matrix? What is the order of this matrix? 3 cross 2. What is the order of this matrix? 3 cross 2. We add these matrices. So 1 will add up to 1. So we get 2. 2 will add up to 0. 0. Similarly, we add this element. 6. 4 plus 2. 6, 5 plus 3, 8, 0 plus 6, 6. So this is our required matrix. Now we will see the multiplication of matrices. So we understand this with the help of example. We have this matrices order n cross n and another matrix of order p cross q. So if we want to multiply these matrices, we can only multiply these matrices when the number of columns of first matrix is equal to the number of rows in second matrix. Then only we can multiply these matrices. So, if n equal to p, then only we can multiply the matrices. And the resulting matrix we get after multiplication will be the order of m cross q. So let us take one example. We have this matrix and another matrix. So first matrix having order, there are 3 rows and 2 columns, and here 2 rows and 2 columns. So the number of columns is equal to the number of rows, so we can multiply easily. So the resultant matrix we will get after multiplication will be the order of 3 cross 2. So 3 cross 2 means there are 3 rows A11, A21, A31 and 2 columns. So, how can we find A11? So, I already told that first subscript always indicate row number and second subscript always indicate column number. So, for calculating A11, we take first row and first column and we multiply corresponding element and then add them. So we multiply 1 into 2, 2 plus 0 into 1, 0. So we will get 2. Similarly, if we find 8 to 1, so here we take row number 2 and we take same column. We multiply 2 to the 4 plus 2 1 the 2. So we will when we add, so we will get 4 plus 2 6. Similarly, we find 8 to 1. So we take one row and second column. 1 0 the 0, 0 into 4. We will get 0 and 8 3 1. We take third row and first column. So multiply corresponding element and then add 3 into 2 plus 4 into 1. 6 plus 4 equal to 10. A 3 2. We take third row and second column. 3 into 0, 4 into 4. We will get 16. Now A to 2. We take second row and second column. So 2 into 0 plus 2 into 4. So we will get 8. So our required matrix is A equal to 2, 6, 0, 8, 16, 10. It is our required matrix. Thank you.